Okay, Brian, that's the Jamboard link, right?
Yes, for the tutorial form.
So this is the one that we have discussed. You can see my screen, all with handwritten. Normal distribution haven't. Question 4 haven't. So, are we doing 4? Tutorial 4, question 4, is it? Can you see the screen or not? Huh? 4 and 5 in each. Oh, so 6 up. Oh, yeah, the checkered bar, I remember. So 6 and 7. Okay, everyone, we're going to do the 6 and 7. Let me read the question 6 first. I hope everyone has finished by now, after 1 week already, right? So you already know probability and probability distributions for the last 2 weeks. We have talked about all this stuff in 2 weeks' time. So for your tests next week, we cover up to this chapter. This morning I already announced that, right? Chapter 1, 2, 3, 4. So including the normal and binomial, everyone. Your course coordinator will post the announcement very soon because I talked to her already. She will post the announcement anytime. Okay, so question 6. The length of the component produced by a machine is found to be normally distributed with an average of 7, and the standard deviation is 0.5. So this is what? 7 and 0.5 squared, right? So you let your x as what? Length of components produced by a machine.
Sir, you didn't record.
Okay.
The mic.
Yeah, by the way, I finished parking. I told you this morning, right? I finished parking. The result is okay. Some are doing very well. Some are doing still okay. Once I key into the Excel, I will show you all. Just now I don't have time to key in the Excel, so most likely whenever I have time, I will post it or I show you all next week. All right. So let's go back to my screen. So A, find the probability that a randomly selected component by this machine has length less than. So how do you write? By right, everyone should know how to write a short form. Okay. So this is a non-standard. You have to change to standard. In a batch of 2,000, how many components to have at least 6.8? Number 1, right? Okay, so at least means what? I will share the screen. Okay, so this one less than 6.8. So we write probability x less than 6.8 non-standard. You already know change to standard. Okay, can do it. Hey, in a batch of 2,000, how many actually components are expected to have length at least? At least means what? More than equal to 6.8. So you find the probability. Actually, more than equal to 6.8, you can take 1 minus this. If you know how to do it. 1 minus this one is actually x more than equal to 6.8. Remember the shortcut formula? Or you want to do normally, you want to change your standard, up to you. You find the probability, and then you times 2,000. Then we give you the number already. So the answer is here. Okay, times 2,000 to the probability, that's the answer. See, 95% of the components, what's meaning 95%? Remember this morning, we talked about the probability, right? Of the component produced by the machine is more than X. Find X. So how do we write? So we have to write this one, right? This is your X. The big X is the length of components, more than. So don't confuse. This is a small x. This small x refer to the length, which you have to calculate. And then the probability here is what? 0.95. So remember, this is what? You need to find the z-score. You have to use what? Table 2. Table 2. Okay? So you change your standard. This one also minus the mean divided by standard deviation. After that, you must determine your z-score, whether positive or negative. Then you calculate your x. The answer is here. I hope everyone have tried that until you get the answer. Okay, number 7. The average weight of a packet of sugar packed by a machine is 500 grams. So the mean is 500, non-standard, and the standard deviation 20 square. Assume that the weights are normally distributed. So we let x as what? Weight of packet. You write yourself, weight of packet of sugar packed by a machine. In a batch of 2,000 packet, how many weight more than 520? So more than 520, change to standard. Once you get the z-score, find the probability, and then times with 2,000. How many? So your probability times 2,000. Your answer here, probability, right, times 2,000. Then we give you the number of packet. 317. Okay, part 2, less than 470. Change your standard also. Find the z-score. Use table 1. Get your probability. Then this probability times 2,000. 3, between 520 and 530. Change your standard, change to Z. Find the probability. Then times 2,000. That's the answer. Okay, part B. Find the minimum weight of the 5% heaviest. What's the meaning heaviest? More than or less than? What's the meaning 5% heaviest? So let's say we want to find what? We want to find the weight, right? So we don't know what's the weight. So let's say A is the weight that we have to find out. Okay. Then 5% means what? 0.05. Fair enough. Probability 5%. Now what's the meaning heaviest? So we use more than or less than? More than or less than? Heaviest, we use what? X more than A. We want to find the weight. So heaviest, we use more than. So from your 5% here, you determine the Z score. So this one you change your Z. This one also minus the mean divided by the, what's the mean? 520. So from there, you find your A. You have to see whether your Z score is positive or negative, because this one is very small, right? 0.05. So it should be what? Positive, right? Because this is more than. So should be right inside. Cannot be negative. If negative, your probability definitely more than 0.5. Okay, so from there, use the table 2, you get the Z score, and then you solve this one equal to the Z, you can get the A answer already. Okay, so let's go through the Jamboard link down. Hope somebody already finished 6 and 7. Which one, Brian? Both also say one.
Yes, both also same.
Okay, everyone can see my screen. So we look at question 6 and 7. Question 6, why no answer? Why no answer? Any one of you want to post answer? Anyone want to post the answer? Yes. We don't want to waste time. Just like I already explained already, right? Question 7 also? No answer. Can someone quickly post it? Anyone? You're posting? If those of you have done already, don't need to wait for each other. Well,
Still, I posted mine in the next page.
next page.
Ah.
Okay. All right. So we quickly finish this so that we can start our tutorial 5. Let X the length of component. Yes. This is your mean. This is your standard deviation. X less than 6.8, right? Yeah. Okay. So I believe everyone already know how to change the standard. So negative 0.4. Wow, it's very small. Normal curve here. Negative, so left hand side smaller. So from the table 1, is this correct answer? Yes, right? Okay, B. More than 6.8. Now, just like I mentioned, you can take 1 minus this. Or, never mind, we see this one first. Let's say you don't know. You just take it as a change to standard. This one minus mean divided by sigma. So you get negative 0.4. See? Right hand side. What is given is here. But what you want is more than this side. So you have to take 1. See, okay, remember total probability is 1 minus the one you don't want. The balance will be 0.6554 lah. And then you times with what? 2000, because the question say 2000 how many? So you take the probability times 2000 now. That will give you 1310 sample. Everybody okay?
Sir,
Hmm.
the answer is 1310, 1311.
What's the answer? 1311. Okay, 1311 because of this round it out lah.
But because the unit not enough.
Never mind, 1310 0.8 so you change to 1311 now.
Okay.
This is a component. See, a component, everyone, component machine usually is a round number, right? Remember, machine, chair, table, all this shouldn't be point form. So we try to round it out to 1311 now. Discrete. Remember discrete? Okay, C. 95%, as I mentioned just now, more than. So this is how you write. X more than X, 0.95. So you see this probability more than half. So your Z score cannot be here. If you put your Z score here positive, more than right inside, right? This is not logic. Because so small, how can it be 0.95? And I told you that day, right? Many times, if you put here negative, more than means here. And this one is logic. Because this is half already, 0.5 plus this one, definitely possible to become 0.95. So that's why your Z must be negative. And from table 2, everyone, you know table 2, right? You look at 0. This one is 0. What? 0.5. Your table 2 maximum is 0.5. So you cannot use 0.95. So you have to use 0.05. From table 2, you can see here 1.644 times. And then there's a negative here. Then you sort it up. You get your X 6.18 centimeter. Multiply lah. Okay. First multiply. And then you plus 7. Okay, any question? Number 6. So after this, you can do past year question. I can also give some extra question, like last week. Do you try out the extra questions? Yes, sir. You try out the extra questions. Okay. Answer for 7. Okay lah. Let me present lah. So more than 520. This is your X. This is your distribution. More than 520, change to standard. So you have 1 positive here. You look from the table 1, this is 0.1587. Okay, then you have to multiply out 2000. How many? So you take 0.157 times 2000. Next, less than 470. Change to standard. You get less than negative 1.5. So here, left hand side, from the normal table 1, you get 0.0668. Multiply 2000, you get 134. And part C, between 520 and 530. So you get 1 and 1.5. Okay, between 1 and 1.5, so you have to find the 1 minus this one. Remember your normal table shaded outside. So 1 you have 0.1587 like this one. Yeah. Okay. You minus the smaller one. The smaller is 1.5 shaded outside. If you look from the table 1, this will give you, okay, this one is 0. So the area trapped between 1 and 1.5 is this one minus the smaller one. The balance will be trapped inside here. Then you times 2000, that is your number. Can? I believe everyone have done earlier. Okay, you just come here and form up your understanding. Any questions you can ask? Oh, where is the part B? Yeah? This one wrong already, is it? Whose answer is this? Should be more than, right? Should be more than. So you let the x more than the k, and here 0.05, right? Heaviest. So we change to standard. This one, so this one is more than heaviest. I assume wrong already, because you use the less than. Those of you who use less than, is the answer correct? Wrong already, right? Hey, how come still correct one? Okay, more than. Oh, your graph is correct. Even though you use less than, but you draw correctly here. Luckily. So you see more than, right? Your Z must be positive, cannot be negative. I told you right just now, if negative means more than is this side. This one is definitely cannot be 0.05. So your Z must be positive here. So from table 2, probability 0.05, you get 1.6449. Everyone? The probability 0.05 is here because more than. So from the table 2, you get this answer. So we compare this equal to positive 1.6449. Find the K, you multiply 20 plus 500, round it up 533. Done. So for your final exam, almost like that. Either use table 1 or table 2. Just go and practice a few more questions, then okay already. You have to be careful. You read the question, you have to use more than or less than, because if you use the wrong sign, your Z score will be different, either positive or negative. So just now, I don't know what's her name. She's very lucky. She used the wrong sign, but she draw at the right hand side. Still correct. Okay, so that's all for tutorial 4. Anyone from at home, you still have any questions? Okay, no questions. So can we start our tutorial 5? This morning, we learned estimation. And after that, we spend a bit time with hypothesis testing. Right? So we close this. Okay, everyone can see my screen, right? This morning we talked about estimation with these two formula there. This is for the confidence interval for population mean, the mu. And then we have another formula for proportion, the P. Okay. And after that, we talk about hypothesis testing. So let's look at the estimation first. One, two, three, four. 1, 2, 3, 4. Is the answer ready? So I just go through fast. This is a live plot, a mean, standard deviation, the mean not known, the standard deviation 500, random sample of 35, and found that the new mean life is 8,900. Determine the 95% confidence interval. So 0.95, right? What is the alpha? 0.05. This morning we learned that. So find your Z score. Now for the confidence interval, your Z alpha must divide by 2 because we talk about left and right, lower and upper boundary. So what is your value from the table 2? And then you put into the formula here, like this morning one, and then you get the answer. Here, for question 2, we have a customer check a random sample of 100. This is your N. Found that 18 were in areas. This is what he had. This is for proportion. Remember the second formula? So we take X, 18 divided by 100, which is 0.18. This is the proportion sample. Then set up a 95% confidence interval. Same thing. Your alpha is what? 0.05. Then you divide by 2, get the same Z score, and then put in the formula, find the CI. Okay, question 3. Random sample of 100 households. So N is 100 in a large metropolitan area. The number of households in which at least one adult is currently unemployed and seeking a full-time job is 12. What does that mean? What's the meaning? At least one adult is currently unemployed and seeking a full-time job is 12. That is what? So you define a p hat also. X over N. 12 divided by 100. That's your proportion. Then estimate the proportion of household with at least one adult unemployed using 95% also. So alpha 0.05. Find your Z score, same, and then put into the formula. Okay, question number 4. 1,000 electors, 20% were found to favor party A. So this 20% means what? Is your P hat, right or not? So sometimes, as I mentioned this morning, sometimes the P hat you have to calculate yourself. Sometimes it's given. So for this type of question, it's given, 20% means your p-hat. Now, 95% again, as I said this morning, most of the question use 95%. So the alpha will be 0.05 divided by 2, and then you can get the answer, same as this one. And then put into the formula, and then you get the 95% CI for the percentage or proportion of electors that favor RTA. Okay, so these are all the answer. Lower, upper boundary. This one got percentage. Question 4 got percentage. Why? Because the question asking for what? So it just times 100%. Yeah. Okay, can we go to the Jamboard link? I hope you all managed to do it this morning lecture. So now, if your time just now, you should be able to do it. No answer. Can you all start doing now? I give you a few minutes. I give you a few minutes. Those of you who haven't done, or those of you who have done one, you can post your answer. Okay. Answer is in. Whose answer is this?
Mine.
Okay, Brian.
Yes.
Okay, Brian, you want to explain your answer?
Let mean equals to population mean life of the particular brand of dogs. Then the standard deviation is 500. The mean is 8,900. Then the total number is 35. And 95% of confidence interval, so 0.05 is the alpha. Then divided by 2 is 0.025. And the z-score is 1.96. So the formula mean plus or minus z-score alpha divided by 2 and times standard deviation divided by a square root of n. Then the lower boundary I got 8,734.35 and the upper boundary is 9,065.65.
Okay, correct. All right. Anyone have any questions? Don't have, Okay, number 2. Any answer? Okay, whose answer is this? Want to present?
It's
Brian,
me.
you again. Why? How come? Where are the rest? I hope everyone have tried that. Not only Brian, no. Okay, Brian, go ahead.
Let P equals to proportion of accounts in areas. Then the total number is 100 accounts. P hat is 0.18 and the 1.1 minus p hat is 0.82. Then the 95% confidence interval, so alpha is 0.05 and divided by 2 is equals to 0.025 and that score is 1.96. Then using the formula given, the lower boundary got 0.1047 and the upper boundary got 0.2553.
Okay lah. So plus minus upper 0.2553, lower 0.1047. Okay, this is proportion, so you use the P formula. Don't use the wrong formula, mean and proportion. Okay. And this morning I explained to you how we get this formula actually from the normal approximation when the number of sample size is big. So the proportion can be actually approximate as the normal, and therefore this is your variance, right? Okay, you will study more about all this in higher level, as I said this morning. Right now, you just memorize or take note of the formula. Because final exam only test two, either population mean or population proportion. So you have to see which question are they asking for. Okay, and this is the p hat. Sometimes it's given, sometimes you have to calculate yourself. Here, the formula is x over n. Number of success or number of events divided by the total n. Any questions from number 2? Everybody sure okay? Okay, we move on. Who's answer? Guys, do you post answer inside? Yes, anyone? Number 4? Maybe don't have time to do it just after the lecture. So understood, but now you can do it now. Anyone just have finished already can post the answer. Oh, question number 4. Oh, what happened to this? Is the answer terbalik? Oh, can some whose answer is this? You want to make it bigger or is it enlarge it? Oh, wow. Okay. Explain your answer. We go to number 4 first, everyone. So 20% means what? The P of Q is 0.8. Alpha 0.05. So again, your Z alpha is over 2. 0.025 is 1.96 from table 2. Yes, who is this? Oh, you want to explain your answer? You see that? Yes, sir. This one. Mm.
So for calculate the CI, we just separate these two and using the formula and put all the number inside. And last we get the 0.1752 and 0.2248 and we multiply by 100% and become the percentage.
Okay. So everyone, the answer given is in the percentage form, right? Just now we look at it. 17.52%. Yes. So you times with 100, right, everyone? No? Sometimes with 122.5%. Okay, number 4 done. Number 3, any answer? Yes, Houston.
My.
Okay, we learn.
Yes.
Okay, proceed.
Okay, I get the sample of 100 households, and then P hat is equal to 12 divided by 100, and then Q hat 1 minus P hat.
So it's
Alpha
a
is
Q hat,
0.05, and then alpha divided by 2 is 0.025. Z score is 1.96. Find from table 2.
So put into the formula.
The confidence interval, just follow the formula.
So 0.0563,
Yeah.
0.1837. Okay.
Yeah. Okay.
All right, good from Greenland.
Thank you.
So as I said, this is not very difficult because estimation only got 2 formula, either population mean or proportion population. Okay. Now, I'm not sure we have the past year question or not. Let me check. If I have past year questions in the notes here, then I will just let me check. So far, I don't see past year. Oh, inside the lecture. Give me 1 second. After this, you can try the past year question. As I said, we may not have time to do revision. Since the first week already, I say after every lecture, every parts of the notes, we can try the past year in your group or alone. Let me open up the past year question. If I find out. Yes, there's a past year here. I just select a few here. You can see my screen. Okay, not every year we have these past year questions. So we will look at the So we don't have much in the past year based on the statistics I have. If any of you have the old version of the past year questions, they might have. So far, I look at the these 3 years, I don't see estimation questions. Okay, so right. So I will leave that to you all to find the past year because my record here, I have 5 set, which does not have the estimation questions. So maybe the old one have. Okay, those of you who find the old one, maybe 2000 and 2015, 2016 and below, they might have a question asking for this estimation. All right. The latest one, few years, don't have estimation question. It doesn't mean it's not important. You still have to know the formula and know how to calculate. Okay, everyone. So that is all for question number 4 and 3. Now let's look at number 5 onwards. We talk about hypothesis testing. Clear or not? This is the one that is definitely important. Let's answer this question. The manufacturer of we try because this morning we have learned a lot. We talk about one-tail test, two-tail test, right? So we want to know whether it's a two-tail, one-tail. We have to look at the sign of H1. Right? Not? Because H1, if you write wrongly, then your two-tail will become one-tail, and your one-tail become two-tail. So you have to know whether the question actually asking test the H0 or test the H1. Remember this morning I talked about null hypothesis versus alternate hypothesis. Okay, let's read the question carefully. The manufacturer of oil additive, certain types of oil, claims that the mean net of the jars, the jars to pour the oil one, is 1 kg. What does this mean? 1 kg means what? Okay, let's read through. A random sample of size 49. What is 49 here? N, clear not? So write down whatever you know. N is 49. Of a large consignment supplied to the company is found that to have a mean weight of 0.98. See, the manufacturer claimed the mean weight of the oil is 1 kg. But after they take the sample of 49, they do the testing and find that the mean weight is 0.98. This morning, what did I say? We are testing H0 versus H1, right? Remember this morning I say girls are smarter than guys. Okay, guys are taller than girls. So H0, is it correct? Or H1 is correct? So the manufacturer claimed the mean is 1 kg, but the testing shows not 1 kg, it's what, 0.98. Now, standard deviation is 0.02. This is our standard deviation, right? Okay, test, this is the very important, the last sentence, everyone. Test the what? Manufacturer claim. What's the manufacturer claim? 1 kg. But our testing is 0.98. So how do you write your x bar? And what is your mu zero? This morning, remember the mu zero and x bar? What's the difference? What's the difference? Both also mean, right? What's the difference? This is the O1. O mean. This is the one claimed by what? Manufacturer. Understand? So what is your mu one? Mu zero? 1 kg. And the x bar is the new mean based on what? Based on the 49 sample. How much? 0.98. So the question now is it the old mean correct or the new mean correct? Am I right? So the question tests the manufacturer. What's the manufacturer? This one, the mu zero. So how do you write? How do you write your statement here? Mu zero has the H no. Okay, O mean you must test the manufacturer claim 1 kg. So your mu zero must be what? 1. That is testing the null hypothesis. So what is the H1? Remember this morning I said these two always contradict one. If this is equal, this one become not equal. Am I right? If this is more than, this one become less than. If this is less than, this one become more than. If this is equal, this one become not equal. Yes or no? And your H1 cannot have equal sign one. H no always have equal sign. Go back to all the notes again. This morning you learn. So when the question says test the manufacturer claim, which is the mu zero, right? You want to test, is it 1? That is put into the H no. If the question says test the new sample, that one is your H1. No? Understand? Some question very tricky one. You have to be very careful. This one is still okay. Now, so if not equal to 1, is this 2 tail or 1 tail? This morning you learn, right? 2 tail. So your alpha have to divide by 2. Remember, this is the rejection area. If your test statistics fall inside here or here, reject H no. That means your manufacturer claim is wrong. H1 will be correct. Understand? Okay, so now can you find the Z alpha over 2 for me? Remember alpha divided by 2, 2 tail. 95%, 0.05. Okay, from the table 2, what is the answer? 1.96. Correct or not, everyone? Table 2, you have seen a lot. So, as I said this morning, your Z test statistics. Now, write down this is the critical value. This is our critical value. Critical value 1.96, negative 1.96. The next thing is you write down the rejection region. Remember, step 1, step 2, Step 3, rejection region. What did I say? If your test statistics, the Z, which you are going to calculate in step 4, is positive, remember this morning I say if positive, you compare with the positive Z alpha over 2. More than means fall right hand side, right? Which means fall into the shaded. The shaded region is the rejection of H0. So here you reject H0, or if your Z is negative, you calculate again negative, and then you compare to negative Z alpha over 2. Which means if the Z here value less than this negative value, which is negative 1.96, it fall also into the rejection area, the shaded area, and again we reject H0. Right? Okay, so this is two sides. Now we have to know whether your Z is positive or negative. So let's calculate step 4. Calculate the test statistics. Remember this morning we calculate what's the formula? X bar minus mean divided by what? Sigma over n. Remember this formula from the notes? Okay, so your X bar is what? 0.98. Always the new one minus the old one. Divided by 0.02 divided by 49. Okay, calculator. Negative minus divided by this, negative 7. Now, you see, I told you, right? Your test statistic can be positive, can be negative. So this is negative. Negative, you have to compare with what? Negative Z alpha over 2. So you compare with the negative 1.96. Right? If you get Z positive here, then you have to compare with the positive 1.96. You cannot compare negative with positive, positive with negative. Cannot like that. So since I write down here, what's our Z alpha 2? Negative 1.96, right? From here. Okay, so negative 7 less than this one. How do you write? Step number 5. Since the Z test statistics is negative 7, obviously less than, right? Negative 1.96, which means the Z test statistics fall inside here, the shaded area, which is what? Reject. So since the Z negative 7 less than this, everyone follow, what do we write? Reject H0. Everybody must do like this. Reject H0 means what? This one is salah already, and H0 is your manufacturer claim, right? Right? Your manufacturer claim, the mean is 1 kg, and it's salah. So the question asks, test the manufacturer claim. Is it true or false? The answer is false. So how do you write the conclusion? Reject H0 at alpha equal to 0.05 and conclude what? The manufacturer claim is true or false? False, right? Or you can say it's not true. Not true means false. If the Z here negative larger than negative 1.96, means fall inside here. Larger means more than, means it fall inside here. Now this one is what? Remember this morning I show you the white color one is do not reject H0. So you have to write do not reject H0. If you don't reject H0 means what? The H0 is correct. H1 is wrong lah. So H0 correct means the manufacturer claim is true. Clear? Anyone cannot follow? You do a few questions, play around like that, then should be okay. So the challenge is what? You have to know how to write your H0 and H1, because from there you know whether the H1 sign is two tail or one tail. Sometimes the question can test H0, sometimes the question can test H1. So make sure you understand the question asking for H0 or H1. All right, and the two sign here always contradict. Hey, can I give you a few minutes? Oh, answer is there already. Whose answer is this?
So it's mine.
Ryan again. Oh, you must like statistics very much. You do very fast. Others?
Sir, for the number 5,
Uh,
is it right if the conclusion that the mean weight of just is not 1 kg?
sorry, again?
The the conclusion the mean weight is not 1 kg again.
Oh, no need. You just mentioned the manufacturer claim is not true. Enough already.
Because the claim is writing that the mean
1
weight of the
kg ba?
just is 1 kg.
Yes, you see, everyone, you no need to write 1 kg one. You say the manufacturer claim is not true. Not true means what? Not equal to 1 kg already. Understood already?
So if I write like this also can.
Yes.
The way I write
Yes,
is
can.
it's not 1 kg. Can.
But better don't write. No need to write already. I'm
Oh.
worried you write wrongly only. So don't overwrite. You write like this.
So just write it's not true.
Manufacturer claim is not true means not 1 kg.
Oh. Okay.
Okay, everyone, you try not to see by answer. You read the question here. Number 7 got answer or not? Number 7, those of you have finished, can try 7 also. Number 8 onwards, don't do first. 8 is proportion. We haven't touched this morning. Most likely I finish it next week. So you'll try 6 and 7. And then you try the past year question also. Then already, 6 and 7. Now, everyone, try not to see Brian answer. I haven't checked whether his answer is correct or not. So try not to copy everything. You read the question. Remember, there are a few steps. Step 1, write the H0, H1. Step 2, write down the critical values, the Z alpha, whether 2 tail or 1 tail. Then step 3, write down the critical region. Okay, step 4, find the test statistics. Use the formula to find the test, the Z value. Then step 5, you make decision whether reject or do not reject H0. And the last step, you have to write down your conclusion. Okay, every time you follow this step, no problem one.
Sir. Sir.
Now remember everyone, the question can test, I write down here, question can test H0 or H1, either H0 or H1. This question tests H0 or H1. Okay, Brian, you may want to discuss. I think everyone have done this. Okay, where are you, Brian? Hilang already.
I'm here.
Read the question.
In the past, the average IQ of freshmen in XYZ University was 124. This year, a sample of 100 freshman students was taken from this university, and it was found that their average IQ was 125 with a standard deviation of 8. Does this indicate a significant improvement?
Okay, everyone. The question not very long, right? So this XYZ university student, IQ in the past means what? Old or new? In the past means old. So 1 to 4 is what? Mu 0. Remember the old mean? This is what I mean. You must know which one is mu 0, which one is X bar. But they don't mix up. You mix up, your minus also wrong already. So what is the sample taken? N is 100. So based on the sample 100, then they do the experiment, and then they find out actually the new mean IQ is what? 125. So 125 is what? X bar. The new mean, old mean 124, new mean IQ 125. Looks like better, right? Increase already, right? So standard deviation is 8. So the new mean say 125 higher than old mean. So just like I mentioned, the question can test H0 or H1. So now can you read this question? Does this show a significant improvement based on alpha 0.05? So everyone, I ask you this question. Is this question testing for H0 or H1? Significant improvement refer to what? IQ. Is testing H2 or H1? H1 is what? Sorry, new mean 125 ma. Old mean 124. So 125 is improved compared to 124, right? So this question asking for significant improvement. So they're asking for what? New mean ma. Is the new mean correct? Is the new mean show improvement or not? Is it the new improvement correct? So that is testing what? Your H1. So how do you write your H1? Mu more than 124. Your H2 this morning, what do you learn? Always contradict, right? You can write, if this is more, your H0 you can write less than, equal, or you can write equal. Remember this morning I say your H0 can write less than, because this one more than H1, so your H0 either you write less than and equal, or you can write equal. Both also can. But the important thing is whether two tail or one tail, you have to decide from the H1 So H0 you write this or this also no issue one. Understand everyone? Okay, so this show IQ is better than last year. That means got improvement. So you want to test whether the H1 is correct or wrong, but we cannot do like that. We only can test what? We only can test the H0. Remember? When H0 correct, H1 will be wrong automatically. If H0 is wrong, H1 will be correct. So H0 say the IQ pass and this year are the same, equal to 1 to 4. Yes, you can write like that. So this is your X bar, alpha, standard deviation. So again, 0.05 divided by, this one is one tail or two tail? One tail. Remember everyone, this is the one tail test, right tail. Right, one tail test. Anyone don't know how to see? More than. So alpha, no need to divide by 2. Okay, no need to divide by 2. So Z alpha 0.05, no need to divide by 2, one tail test. Table 2, is this correct? 1.6449. Okay, and then based on this morning curve, I mentioned that Z alpha here is 1.6449. So any Z test statistics you calculate more than this, remember the rejection region, more than 1.6449, you fall inside here, reject H0. If the Z value less than this, you fall inside here, the white color one do not reject H0. So let's calculate the Z. X bar 125 minus the 124 mu 0, the old mean, always the new minus the old, divided by sigma 8 divided by cert 100. So calculator, you get 1.25. Yes, right? This is positive, you see? Why positive? Because this is right tail. See or not? You sure get positive one. Because more than is already right tail. You cannot get this one negative one. I told you, right? You cannot get negative compared with positive one. No such thing. Unless this is left tail, smaller. Left tail, negative, 1.6449. Then this one you get negative. Then you compare with the negative. Understand? Anyone don't understand? Anyone need me to repeat? Oh, very good. Everybody can understand. So let's make the conclusion. Since 1.25 less than 1.6449, right now, mathematically. So if 4 inside here, less than means if 4 inside here. Only more than 4 inside here. So here is what? Do not reject. Remember this morning? This one reject. This one do not reject. So we say accept. Accept means do not reject everyone. Agree? Accept is the same meaning as do not reject. Mathematically English. So either you write accept or you write do not reject. Sama saja. Do not reject H0 at 5%, which means your H0 is what? Correct. Don't reject Correct this means what? Your H1 sudah salah loh. Remember I say H0 correct, H1 will be wrong already loh. And the question testing H1, right? So H1 salah. What's your conclusion? The IQ, the question asks, is there any significant improvement? So what do you conclude? You can say the IQ for the last and the past year, this year are the same, or you can say, or now those of you who want to write this also can. You can conclude that there is no significant improvement of the average IQ in the of freshmen in XYZ Institute. So whether you write here the old and the new IQ is the same, or you can write here there is no significant improvement because we reject what? H1 right? H0 correct. Do not reject H0 means the last year and this year IQ is the same, no improvement. Anyone don't understand? Okay, so for question 7, anyone have done? My laptop not much battery already. So do I want to continue next week or what? Will I bring my charger? Where's the charger? Yeah. I'm not sure can or not. How long can tahan the laptop if there's no symptom show low battery? 10 minutes. Half an hour. Do we have enough time? Are we doing question 7 next week or now? Next week. Okay, we do next week, everyone. Oh, actually the 7 is here already. Okay, let me quickly just go through. I hope you're done already. You read the question already or not? So test, this is 10% level of significance. So it says that the hour which with the mean 7.6 and the standard deviation 0.6. A large company take a random sample of 50 and test the average hour, which is 7.5. So what is your mu0 and what is your x bar? Mu0 is the O1, right? What's the O1? 7.6. And then the company takes sample 50, N is 50, right? And then they do the testing, they find that actually the new mean is even worse, $7.50, dropped by 10 cents already. So which one is correct? Old one or new one? So we test at 10%. 10% means what? What's the alpha? 0.1. Remember? 10%, 0.1. So is this two tail or one tail? Okay, you read the question. Can we conclude that this company average hourly wage is less than the entire industry? This is the entire industry. The O1. The company one, 7.5. So this statement has H0 or H1? Can we conclude that this company average hour is less than? So are we testing H0 or H1? Everyone still there? Can you hear me or not? Okay. Charge battery already. Okay, let me finish that one. So sorry for the battery. I thought I don't want to continue this one. Never mind. So 0.1. Can you see my screen? I share first. No more class, right? After this? No more class, right? Okay. Okay, can you see it already? Okay, let me finish this. So this is alpha 10%. Now, can you write the H0 and H1? This is the question asking, is the company wage is less than? So how do you write? We test the H0 or H1? H1, right? So you write the new less than means the industrial one is what? 7.6. So remember, if this H1 is less than, This is one tail, right? Remember this morning we learned this is left one tail. And your H door, how do you write? You can write here equal, or you can write here more than, equal to 7.6. So you see, you must know whether it tests H2 or H1. So left tail, and what's the answer here? You can write equal or you can write more than. So this is less than. Okay. Company which is less than the industrial one. So alpha 0.1. Now, one tail alpha no need to divide by 2, right? Right. So from the table 2, is this correct? Correct. Now, why there's a negative? Because it's left tail. Left tail means what? There is a negative here. From table 2, you get 1.2816, correct not? So you calculate your Z test statistics, step 4. New mean minus old mean divided by sigma 0.6 divided by Z50. You will get negative 1.1785. You see, negative. You must get negative 1 because you compare with what? Negative 1.2816. Now, if this value less than this value, you fall inside here. Reject. If this value more than this value, means you fall inside here, the white color one. Do not reject H0. So mathematically, negative 1.17 is more than negative 1.28, right? So it fall inside here, lor. More than, so right hand side, lor. Understand? Less than means left hand side. So fall inside here means do not reject. Or you can write accept H0 lah. Sama meaning at 10% significant level. And what's your conclusion? Do not reject means H2 betul, H1 salah. So you conclude what? The question asking is the company which less than. So H1 salah, right? So what is your conclusion? Mean the company which, you can write here, either you write here the company and the entire industry is the same, or I prefer you write like this. Conclude that the mean company which is not less than, because your H0 here is less than, H1, sorry, you reject already, right? So it's not less than. Everybody okay? So that is the 2 questions what we have learned this morning, and you try now. So when you do your first question, be careful. Read the question, test H0 or H1, so that you know whether it's 2 tail or 1 tail. 1 tail, is it left or right? Okay, so we continue next week, do the proportion, and then I will start with chapter 6. Any questions? If no, that's all. Bye-bye, everyone. See you next week.